Hello, welcome everybody. Here is your lesson on section 4.1 in your geometry class, angles and triangles. So I'm going to go fast through the first few slides, so if I'm going too fast, feel free to stop the video so you can record the key vocabulary words. So your title, 4-1, Triangles and Angles. We're going to start with triangles can be classified by their side length. So when you look at this slide here, side length are the sides of the triangles. So when you're talking about like this side, and this side, let me make that a little bit larger for you. Okay, so these three sides right here, if they happen to all be the same, and they are here, when you have three sides that are equal or congruent, equal in size or congruent, then that triangle is called equilateral, just like equal means same. Isosceles is when two sides are the same or two sides are congruent, and scalene is where no sides are the same. What happens if you're talking about the angle measure of the triangles? Well, an obtuse angle is an angle larger than 90 degrees and less than 180, and an obtuse triangle will have one of those angles. That angle there is an obtuse angle, therefore we call that triangle an obtuse triangle. Right triangles contain one right angle, indicated there. Acute triangles are triangles that are probably the most popular, along with right triangles, and those are when all three angles are less than 90 degrees. And equa means equal again, so equiangular means the same, means all three angles are equal. Now here's example 1. So example 1, part A, is about architecture, trying to relate this to the real world. The frame, so when I'm looking at this, the frame of this window design is made up of many triangles. Classify triangle ABC. So I'm going to highlight ABC so you know which one I'm talking about. I'm talking about this one right here. So let's look at our choices. Our choices are acute, equiangular, obtuse, or right. So all four of these classifications deal with the angle measurements. So I don't have to do the first vocabulary words I talked to you about, which was like equilateral, things like that. So acute means all three angles are less than 90. Well, that looks acute to me. Are all three angles equiangular? I don't think so, not the way these look. These two may be the same, but this one definitely is not the same, so I don't think it's equiangular. Obtuse, nope, sorry, there's no right angle, there's no bigger than 90-degree angle, and there's certainly not a right angle, so this one would be acute. Moving to example 2. Now for example 2, we need to name, so we need to name a triangle that's isosceles and scalene. So you have to remember your vocabulary words, work at them. Isosceles means two sides are the same. So when I'm looking at this, I see that side and that side are the same, but if I just look at the separate angles here, and let me, since Star Wars is coming up very soon in the theaters, let me go to the lightsaber. There we go. So this little triangle here has this side, but it's the same as this triangle and this little one. But what happens if these two triangles are put together? You have a bigger triangle. So that bigger triangle I'm talking about right here is A to E to D. These two sides are the same in AED. So for an isosceles triangle, that would be triangle AED. That's how you label or you name a triangle by the three letters, which are the vertices or the corners. Scalene is where three sides are different. So there's lots of these. You could have multiple answers. I'll change colors to blue here. So when I'm talking about a scalene triangle, this side is longer, this side is shorter, and this side's like medium. So I would call this triangle ABC. A lot of times your books will put them in alphabetical order, but it doesn't have to be, just like I didn't here. And that would be your scalene triangle, although there are many answers for this one. When you get to example 3, Find D and the measure of each side. So reading the question out loud, of the equilateral triangle KLM. Okay, so now I got more information. KL has a length, since it's two letters without the symbol, this means length, so it's a length of D plus 2. And LM is 12 minus D. I like to label my pictures. Feel free to stop the video if I'm going too fast. And KM is 4D minus 13. Well, you need to first of all understand what kind of triangle it is. It's equilateral. So equilateral means all sides are the same. So when I take this side and this side, it doesn't matter which two you start with, they happen to be the same. Same means equal, because equilateral is equal means same. So I'm going to put D plus 2 equals 12 minus D. Why did I pick those two and not use this side? I don't know, bigger numbers, that would be my only choice. So I need to solve this. Feel free to stop the video if you want to try it on your own. But you get rid of that minus D by adding it. You get 2D plus 2 equals 12. Then you minus 2, 2D equals 10. Divide by 2, D equals 5. So that's D. So it said find D. Yes, I did it. And the measure of each side. So now when I find that 5, I substitute it in there. 12 minus 5 is 7. And since it's equilateral, I better get 7 for all of them. Let's check it out. 5 plus 2 is 7. And just for this side, if I plug in a 5, I get 20 minus 13 is also 7. So I verified it that all sides are 7, given the information I knew. Now, sometimes it's on a coordinate plane. Now, this is where the problem gets a little tricky. So I'm going to kind of move this over a little bit. Actually, I'm going to read it first and kind of move it up over here. Find the measure of the sides of RTS and then classify it by its sides. So its sides are like equilateral, isosceles, etc. from the first slide. So you need to find the measures of the sides. So you need to find the length. So finding these lengths, you have to go back to something from early in the year. It's called the distance formula. These are at angles, so you can't just count. So the distance formula, if you remember, is x2 minus x1 squared plus y2 minus y1 squared. So then you take the x values to find the length of the red side, subtract them. So you get 8 minus 4 or 4 minus 8. Doesn't really matter because you'll square it, it'll be positive anyways. And then you take the y's, 4 and negative 1. So if I started with the 8, I better start with the negative 1. Negative 1 minus 4 squared. So I'm going to try to shorten this up here. So this is 4. 4 squared is 16. This is negative 5. Negative 5 squared is 25. And 25, 35, 41. This is the square root of 41. You could figure out what that number is if you want to, but for this purpose, it's not necessary. I'll change to blue to do this side. Kind of try and squeeze this all in on one slide. This is going to be tough. So square plus square minus minus. Okay, so I take the numbers. So I'll take 8, or I'll take the negative 1 minus the 8. And then I take the negative 3 minus negative 1. This is going to be tough. I don't know if I can squeeze it in there. Negative 3 minus negative 1. That is a negative 3. So this is going to be a little tough here because I'm running out of room. So this would be negative 9. Negative 9 squared is 81. And this would be negative 3 minus a negative is a plus. That becomes negative 2. Negative 2 squared is 4. So this becomes the square root of 85. Now, does it look longer than the red side? Yes, it does. So I think, unless I made any mistakes, that I'm accurate. Now I'm going to change to black and kind of try to do the black side. So the black side is the square root of something squared plus something squared with minuses in between. You get negative 1 minus 4. This is a longer problem, but you gotta have patience. Negative 3 minus 4. Negative 1 minus 4 and negative 3 minus 4. Good. So this is a negative 5. Negative 5 squared is 25. And this is negative 7. Negative 7 squared is 49. 49, 59, 69, 74. Square root of 74. So I hope I didn't make any mistakes there. There's a lot of math in those, and I hope I didn't make an error. But since all three sides are not the same, this would be classified as a scalene triangle. Okay, moving on. Oh, I end with a little cartoon. I hope you get the joke. It's one of my classic favorites. Acute. Acute. Thanks for coming today. That should be all you need to do. Thanks for listening.